Alright, welcome back to the programming language series where we're going to be making a statically typed and JIT compiled language using nothing but Python and LLVM. Last time we went through the user-defined functions, we implemented our main function, and we finally decided to run our program. So this time we're going to go into something a little more simple, into a variable reassignment. So this is the chunk of code we're going to be compiling and running today. We just have a main function. We have our let statement initializing a to 4, and then we're going to reassign that a variable to 4 times 2, which should be 8. And then we're expecting to return the number 8 for this program. So that's where we'll get started off, and this is where we should end as well. So down in the ast.py will be our first stop. We're going to add a new node type called the assign statement. So assign statement, if I can spell. And we're going to go down to the bottom of our statements and create that class. For the sake of time, I'm going to paste this in, and you guys can pause the video and copy this down. Basically, the assign statement is going to take an identifier, which I just have expression because, as I've done in the past, I cannot use the identifier literal because that is declared down here. And it just makes more sense for literals to be down there, so I refuse to move it. But the identifier literal, and then it has a right value, which is just the right side of the equal sign, and that's any kind of an expression. And just same as always, type in JSON. So I have that copied down, and we'll move on into our parser. So moving into our parser, let me save this. In our parser, we're going to first import the assign statement. So assign statement. We're going to go down to our parse statement function. In our parse statement function, we are going to have an if statement at the very start, self.currentToken.type. If that type is an identifier, and the peak token, so token is equal to the equals token .eq. We want to not even go to this match statement. We'll just go straight to self dot underscore parse assignment statement. So if the current token is an identifier and the next token is an equal sign, we know, of course, we're going to be at an assignment statement. So let's jump to that. So moving down into the assignment statement, we'll just scroll all the way down here. Def parse assignment statement, take in a self. This will return an assign statement. First thing we're going to need is just a statement variable that's going to initialize our AST node for assign statement. We're going to set that identifier equal to a value, self.currentToken.literal. We're going to do self.nextToken a few times. The first one's going to skip the ident token. The second one's going to skip the equal sign token because we already know it's there. We don't need to do anything with it. We're going to set the statement.write value. We're going to parse the expression. So use our parse expression function with the lowest precedence type just to start. We're going to advance the parser again with next token. And then we're going to return the statement back out. So that's actually everything we need for the parser for reassignment. So we'll go back into the main.py file. We'll change that to false. And we'll go to parser.debug, turn that debug flag to true. We'll do python main.py. There we go. So we got some AST. So we got an ast.json, so we'll go into this and just kind of check it out. Put test.lime over here. So first thing we have is a function statement. The name of it is main. We got all that. Body, block statement. We have our let statement. And then we have our new node, which is our assign statement. The identifier is a. The right value is an infix expression, so just a times 2. So this AST checks out. Everything's looking good. So we'll close out of that, close out of the AST. We'll set this back to false. Just go ahead and set compiler to true for later. because that is where we're heading into next, which is our compiler.py. First thing we're going to do is import our new assign statement. At the very bottom of this init function, I'm gonna paste in an errors list. So it's just gonna keep track of errors temporarily. They're gonna be strings. Eventually we'll have an episode that goes a lot more of a deep dive to make these errors actually do something helpful. For now, this list will do. Then we're gonna add in our compile statement, we're going to add our case node type dot assign statement. And that's just going to be a __ visit assign statement. Pretty similar to every other feature that we are adding. It's kind of, I'm hoping you guys are seeing the kind of method we're going through. We're moving all the way from our token class all the way up to the compiler. So it should be starting to make a little more sense now. So for our visit assign statement, I'm just going to copy this right here and scroll down to the end of our statements. Make a new function, visit assign statement, self. The node will be of type assign. Won't return anything. So the name, we're gonna have a name variable, should be our string. So we're gonna grab that identifier value from the node.ident.value. We're gonna grab the actual expression value from node.writeValue. We're gonna compile that expression and resolve its value. So self.__ resolve value. We'll pass in that expression node. So we're going to have the last thing is our if statement. So if self.env.lookup, so we're going to look up the name of this variable. If that doesn't exist, we're going to append an error to the list. If it does exist, like we want, we're going to set pointer and then underscore just because we don't care about the type that comes back. Self.env.lookup. We're going to look up that name. Then we're going to use our builder, self.builder. We're going to do a store instruction. We're going to store this value to this pointer. So we're going to store this new value to the pointer of our variable, which in this case will be a. We're going to store whatever a times 2 is to the same memory location that a is in. So that pretty much makes a equal to a times 2. Now that that's implemented, we're good to go back into main.py. Make sure that compiler flag is set to true. We'll do python main.py. We'll go into our IR code, take a look. So we'll grab our test.lime as well so we can see them side by side. So we got our main function. We're going to load that value, that integer value from a. Then we're going to multiply that value by 2. We're going to store that back into a. We're going to load it again, and then we're going to return whatever a is, that variable, back out. So this IR is looking good, so we can set our run code flag to true and kind of investigate what this brings us back. So python main.py, program has returned 8. So that's perfect. So we can go even further. So a equals a times 2 again. So 4 times 2 is 8, like we got before. So this should give us back 8 times 2, which is 16. And it does. Perfect. So this is variable reassignment implemented. If you have any questions, comments, concerns, have another feature you guys want to see, or see the schedule of this series, please join the Discord. The link is down below. Anything else you guys want to see, just leave it in the comment section or hit me up on Discord. The next episode on the schedule is implementing if statements, our conditional operators, and booleans into our language. So I'm excited to get that out. So I'll see you guys in that episode.